Hi students, in this video we are going to learn about integrals of particular type. We will just look at the type. The type is integration of e power ax into a into f of x plus f dash of x dx. If the integration is in this form, then we will follow the algorithm. The algorithm says that we just need to multiply this e power ax inside the bracket so that we get two different integrals. So integration of e power ax into a into f of x dx plus integration of e power ax into f dash of x. After that, what we need to do is we need to assume this integration as I1 and the second one as I2. Then we need to work on this first integration and maintain the same I2 as it is. By solving this I1, we will get an answer. With that answer, the I2 will get cancelled. That I read out that sentence. The term obtained by integrating I1 will cancel out with I2. So we will get the final answer. We are not going to work on this integration 2. We will work on integration 1 using by-parts concept. The answer that we get will cancel out I2. So we will get the final answer. I will explain this concept through an example. I'll take this example. Here the question is integration of e power x into cot x minus cosecant square x. First we need to confirm that the question is of this form. You just check the derivative of one function. You just check the derivative of cot x whether you are getting this cosecant square x. Otherwise check the derivative of cosecant square x whether you are getting cot x. So you need to check with both. Here it is an easy sum. So as soon as by looking at the question you can say that derivative of cot x is minus cosecant square x. So you can compare it with the model we have, that is e power ax into a f of x plus f dash of x. We can say that f of x is cot x and f dash of x is minus cosecant square x. Here a value is equal to 1. On comparison, we just come to know that a value is equal to 1 and f of x is equal to cot x and f dash of x is minus cosecant square x. So after coming to this, what we need to do, we need to multiply this e power x inside the bracket and make this as 2 integration. That is what is done here. So e power x into cot x dx plus e power x minus cosecant square x. You know that this function f of x integrand should be considered as integral 1 and f dash of x, the integral which contain f dash of x, should be considered as I2, and we will work on I1 only. So just we are evaluating integration 1. Here integration of e power x into cot x dx. It is in the product form, hence we can apply by-parts theorem. As per the by-parts theorem, we need to choose the first function and second function. You know that for that we will use Eilert concept. As per Eilert concept, trigonometric comes first and exponential comes next. Hence cot x should be considered as the first function, e power x should be considered as the second function. Now we are applying by-parts concept. First function as it is, integration of second function minus whole integral of derivative of first function into integration of second function dx. So I am just rewriting this e power x into cot x minus, we know that derivative of cot x is minus cosecant square x and integration of e power x is e power x. So just we are rewriting it, minus into minus becomes plus. So e power x cot x plus integration of e power x cosecant square x dx. We need not proceed further here with another by-parts concept. Here you just compare it with I2. Now we have seen that I is equal to I1 plus I2, right? I2 is written here. I am just taking out the minus sign. So in this place I1 we will substitute this expression. So e power x cot x plus integration of e power x cosecant square dx, this minus sign as it is, and then this integration 2. These two will get cancelled. If you look at this is plus e power x cosecant square x, this is minus integration of e power x cosecant square s. Both of them will get cancelled and we will get the final answer as e power x cot x plus c. I hope you understand this problem, and it is a much easier and shortcut method. In the next video we will see some more problems related to it, so you will be confident with this technique. Thank you students, thanks for your cooperation.